All right, so here's another one of these exponential problems. Again, this one has to do with money, and so it was one of the ones that was kind of commonly missed or somewhat commonly missed. And so I want to kind of go over it, discuss, what it is that I'm looking for, and then also help you to solve these because it's definitely something that could possibly come up. So what it says is find the time it takes for $8,500 to double when invested at an annual interest rate of 19% compounded continuously. Okay. So again, like we talked about in some of the last problem, what we have here is we have one is my A is going to equal 8,500, okay? And my interest rate, we'll call it I, is going to equal 0.19, so it's 19%. So what we're going to do is we need to find that B value. B, which is going to be the B inside of A times B to the T, which will give me the value of what I have inside of my account. So B is just going to be, in this case, it's going to be 1 plus 0.19 because it's interest. Okay? So this is interest implies addition when we're talking about like a bank account. Now, if we're talking about a credit card, for example, they're going to be taking it away from you, but for the credit card's purposes, the credit card bill is getting bigger and bigger and bigger, so hence we're still going to be adding, all right? So that gives me my B of 1.19. So consequently, my model is going to end up being 8,000, or V of t, excuse me, V of t is going to equal 8,500 times 1.19 to the t. Okay? Now, this question is asking us, well, what happens, like when does it end up doubling? Like how long does it take to double? And so what that means is that doubling is going to imply 2 times 8,500, which is 17,000. Now, just like a lot of these other problems, okay, what we're going to end up with is, in this case, we're going to end up with, on the V of t, after we do a little bit of algebra, we're going to end up with 2 equals 1.19t. Okay, so you can actually kind of go directly to that if you want to. But for our purposes, and for the purposes of demonstration, we'll have 17,000 equals 8,500 times 1.19 to the t. Okay? Then we'll divide by 8,500 because we're looking to isolate t. And so that means that 2 equals 1.19 to the tth power. Just like before, algebraically, in order for us to bring down that t so that we can then isolate it, we're going to take the natural log of 2, and that's going to equal the natural log of 1.19 to the t. And that is then, so ln of 2 is going to equal t times the natural log of 1.19. Then it's just a matter of t will equal natural log of 2 divided by the natural log of 1.19. Okay? So consequently, we'll go in, we'll have 2 natural log divided by 1 natural log. And that'll equal 3.984 or 3.985 years. So t, in this case, equals 3.985 years. Now, the second problem asked us what happens if we change the principal, right? Okay, so now for part B in this case, now A equals $850,000, but it's still otherwise the same problem. Like how long does it take to double? Well, it turns out it doesn't matter, okay? Because, 2 times A is going to equal $1,700,000. And then I'm going to set up my problem as $1,700,000 equals $850,000 times 1.19 to the t. And then when I go in and I divide again, okay, divide again, what I end up with, or what I'm left with, is 2 equals 1.19t to the t. Well, take a look here. These two, they're exactly the same. And so this whole idea, whether we're doing half-life or doubling, like when does it double, those problems are actually independent of your initial value because after algebra, you're going to end up with zero point 0.5 in the case of half-life, or in the case of this doubling, you're going to end up with 2, right? And then so what happens? Well, we already know that once I get to 2 equals 1.19 I am going to then, do my algebra, and I'm going to end up with t equals 3.985 years. So what that tells me, all right, so what that tells me is the rate at which the account changes, doubles, whatever, is only dependent on the interest rate or the rate of decrease. Kind of a handy thing to know. We don't actually need those principal amounts. All we need to know is how fast is it decreasing, how fast is it increasing, right? Like how long does it take to double, how long does it take to cut in half, and then that'll allow us to figure out what its rate is, right? And then we can actually develop our model. Okay, cool. So that's it. That's another example, same basic kind of problem. In this case, what was happening? We were doubling. So that means that we were looking to increase, right, this interest rate. So big thing here, remember that if you have an interest rate, you're going to be adding a certain amount, right? And then it makes sense that it would be, if you're going to actually double, you have to be increasing the amount that's in the account. So hence you're going to have to be adding. Okay? All right, cool. There it is.